Okay, so as I said in class, I'm only going to touch on the high points of example 1 because it will graph a lot like graphs that we have already seen. I just want to show you more of the simplifying process this time around because this one does factor a little bit more than the others have. So as far as the simplifying goes, I'm just going to jump up here and do it. That numerator would factor as x minus 2 and x plus 1. And that denominator would factor as x minus 1 squared. So it's factored, but nothing cancels, and so there's still not going to be any holes in this graph. We still haven't seen any holes on our examples yet, but what this will alter about the problem is that now when we do the R step, we're going to have two answers. So we'll take the numerator, both factors of that numerator, and set them equal to 0. And so we would have x is equal to 2 and x is equal to negative 1. And when we do the A step, we're only going to get one answer. We have one factor in our denominator, it just occurs twice. So when I take that factor in the denominator and set it equal to 0, I'll just get x equals 1. That's my vertical asymptote. But that factor was in the denominator squared, so what that tells me is that my branches are going to move together at that one and only asymptote. Okay. Now the other thing that's slightly different this time that we haven't seen before, I mean you saw it on the homework but not on the notes, is the end behavior. This time our leading terms are balanced. We're going to have x squared as the leading term over x squared, which is equal to 1. So we're going to have a horizontal asymptote of y equals 1. Okay, and then of course last but not least, when you plug in 0, you're going to get the y-intercept. Now in this case, it's actually easier to look at the unsimplified form of the equation, because if I plug 0 into this form of the equation, those terms would go away, those terms would go away. I would just have negative 2 over positive 1, and so I would get that. Okay, so this time the SHRATEY steps will give us more of the graphical characteristics. Not a ton, but that's actually okay because we're not going to need a ton. Our graph is only going to have 2 branches. So that's why it's graphing similar to stuff we've already seen. And we've already seen t behavior on a couple of examples as well. And so I'm going to have one vertical asymptote. I'm going to have one horizontal asymptote at 1, right there. And I've got 2 roots. I hit here, and I hit here, and I've got a y-intercept. So we actually have enough information to graph this now, and that's because of the other characteristics. We know that we're going to go through these 2 points. We're going to curve to follow that end behavior asymptote. We're going to plummet down and curve to follow that vertical asymptote. And as far as the right branch goes, we know that we have to move down this asymptote. Oops, I just resized the graph. We're going to move down that asymptote. So I know it's going to head down that asymptote because I know that my branches have to move together at that asymptote, and I know it's going to hit the x-axis and come up and curve to follow that end behavior. Okay, so I actually had a pretty decent sketch of it without doing any table of values at all. But what I really want to do is I really want to concentrate on these 2 examples because these will have slightly different characteristics that we've never seen before. So example 2, the first thing I'm going to do is I'm going to simplify it, and this one does simplify. We've got 3x squared on top, and on bottom I'm able to pull out my greatest common factor. Oops, that's an x minus 3. And so this x will cancel with one of those x's. And so my simplified equation is 3x over x minus 3. And the fact that I had a factor that cancels means I do have a hole. So remember how we locate holes. It's 2 steps. Step 1 is the x value where this factor would have had a vertical asymptote. Tells us the x value for the hole. So that vertical asymptote would have been at an x value of 0. Okay, so that's step one. Step two is I need to actually calculate the y-coordinate for that hole, because a hole is a point, it's just a hollow point, but I need to know both coordinates to plot that point. So I plug 0 into the simplified equation. There's a reason we always do S first. Okay, and the reason for that is that once you've done S, everything else really needs to be done with the simplified equation. Okay, and we'll talk about examples about what's going to happen if you don't realize an equation simplifies, and it should have. You're going to see those on the homework over the next 3 days or so. But when I plug 0 into this equation, I just get 0 as my answer. So that's going to be my hole. Okay, so now I've got my hole and my simplified equation. So I do the R step with the numerator of the simplified equation. I set it equal to 0, and I get 0. Now, at first glance, that looks like a perfectly acceptable answer, but keep in mind, we just figured out that 0 was our hole. So that means that, yeah, it's going to hit the x-axis, but it's going to hit the x-axis with an open circle. Okay, so it's not really a point hitting the x-axis. Then the A step, we take our denominator and set it equal to 0, and we know we're going to have a vertical asymptote at x equals 3. There is no special squared factors, so no t-step. The E step will take the leading term of the simplified numerator and the leading term of the simplified denominator, and it reduces down to a constant. So this time we have a horizontal asymptote at y equals 3, so it's a constant. And then when we attempt to plug 0 in, we get 0 as our answer again, but we know that can't be happening because that's the hole we'd have already determined. Okay, so this time you would need to do a little table of values. It wouldn't need to be terribly big, but we could go ahead and draw that graph. 3, 4, 5, 6, 2, 3, 4. Okay, I'm going to change colors here. Okay, so I have my hole here at 0, 0, and I have my vertical asymptote at 3, and I have my horizontal asymptote at 3. Okay, so you need to do a table of values. You're going to pause, and you're going to do a table of values. For the left branch, you want to do an x value immediately before the vertical asymptote, so you're going to do x equals 2 and see what you get. And then you want to pick your own. Pick a number farther down towards the left end. So I'm going to go ahead and just do 6. So I'm going to plug in -6. Okay. And then for the right branch, you need to choose the x value immediately to the right, which is 4, and then choose at least one other number farther down to the right. Whether you choose 1 or 2 will depend on how quickly it looks like it's approaching that horizontal asymptote of 3. I mean, if you choose a number like 9, and you get a number that's already really rapidly approaching 3, then you don't need to do another number, if that makes sense. So I want you to pause, and I want you to do some number crunching and practice that, and we'll see what you guys got. Okay, so what you can see here is that these two x values gave you really nice, pretty y values, and that gave you really good shape on that left branch. Okay. Now the right branch, I'm not going to be able to draw because it always wants to act like I'm messing with the toolbar on this thing. But you're going to have a graph that goes way up off the top edge because here your y value should have been 12. And then here what this shows you, 4.5 mathematically is really not approaching 3 yet. So you're going to want to try a number even farther out, maybe 12 or something, just till you can see that curve and see it begin to level out. But what you're going to have is a graph that looks like that. It's going to be up above the horizontal asymptote and curve to follow. over there. Okay, I'm just going to be up off the top edge. I can't graph it. Okay, now, example 3 is where we're going to stop for tonight. And I think you guys will be really pleased with how this turns out. I'm not sure why on this screenshot the equation isn't there, so I'm going to just write it down over here, or up over here. So this was my original equation. F of x is equal to 3x squared minus 12 over 4 minus x squared. Okay. Now, if you have a graphing calculator, I want you to go ahead and pause for a second, and I want you to type that in your calculator. And I want you to see what you get, and I want to see if you can figure out why you get that. Because there's an amazing thing that happens with this equation. So if you have a calculator, pause. If not, that's okay. I'm going to keep on going. Okay? Okay, so for those of us who don't have a calculator, or for those who are just on pausing now, because they did have a graphing calculator, this is what happens when you simplify this equation. Start by pulling out a 3 from the numerator, and it becomes x squared minus 4. Okay? But then I look at the denominator, and I see that it looks an awful lot like x squared minus 4, except everything on there has a sign change. So I pull out a -1. And when I pull out a -1, it changes the sign on everything. So the x squared becomes positive, and the 4 becomes a minus. And so that means that the entire equation simplifies and reduces and becomes -3. That's it. That's your entire equation. So your equation is y equals -3. It's not a horizontal asymptote equation. That is your actual equation. Now, there's obviously one trick to that equation, but what that tells me is that my entire equation became a horizontal line. Okay? So don't forget, I'm going to draw this horizontal line here, but don't forget that the entire graph does not look like a horizontal line. Can anybody, I'm hoping you guys are thinking, I know what's there. Something canceled out of the equation that's going to leave holes behind. So I'm going to have holes. Now I can either factor the part of the equation that I had canceled out so that you can see where the actual holes go, or we can just solve it. X squared minus 4 would have factored as x plus 2, x minus 2. And so those canceled and those canceled. That's why the whole quadratic canceled. So what that means is that I'm going to have a hole with an x value of -2, and I'm going to have a hole with an x value of +2. Okay? As far as the y value goes, I don't need to calculate it. My simplified equation is a horizontal line. So everything about my graph has to be on that horizontal line. So both holes have a y coordinate of -3. So what you would do is you would come in here and use your eraser or whiteout if you guys like to graph in pen, and you would put a hole at -2 and a hole at +2 on your horizontal line. And those you would not have seen on your graphing calculator, but what you would have seen is the same thing we did back in September. You would have had this complicated equation that graphed as a horizontal line, and you would have known, wait a minute, there have to be holes in that graph, and you would have looked in the table for them. Now, the especially nice thing about this is that once this equation simplifies so drastically, then you look at this, that graph has no roots, never hits the x-axis. It has no vertical asymptotes anymore because they were moved from the equation, they became holes. It's not a rational function at all anymore, so it won't even have these characteristics. Lines don't have tangent behavior and end behavior that we analyze. And the y-intercept is -3. That's it. That was the entire analysis. Okay? So simplifying can save you a ton of work if the equation does simplify, but you do have to remember how to locate, and that you do need to locate holes. Okay? So that's it for tonight. Tomorrow we're going to do the back of the notes as our warm-up / practice again, just like we did today, and then you'll have the rest of the period to finish worksheet 1 and get it turned in. Okay, so come in for tutoring. You guys only have a week and a half until the test, so you need to be keeping up with this. Thanks.